In this tutorial screencast, we're going to look at the nomenclature of alcohols and ethers. So let's approach this from a point of view where we're given a molecular formula. Say we're given C4H10O. And let's draw all the possible constitutional isomers of that molecular formula and then name them. So as always, the first thing you want to do is determine how many degrees of unsaturation are present in a molecular formula. So we're going to use CnH2n plus 2 and realize that oxygen does not add or subtract to the hydrogen count. So we can basically ignore it. So for C4, basically we're ending up with 10 hydrogens anyway, so this has no degrees of unsaturation. And so why is that useful? So basically with oxygen containing functional groups, the only thing that we have to consider is alcohols or ethers. And so that sets up the nomenclature aspect of this problem. And so what I want to do is divide the whiteboard here into two. So on this side I'm going to write ethers, and initially on this side we're going to look at the alcohols. So for C4H10O alcohols, let's start with a C4 chain. So let's go ahead and draw a C4 chain. And so basically we have to consider putting an oxygen on this chain, and let's do it in a logical fashion. Let me go ahead and number here 1, 2, 3, 4. And let's go ahead and put the OH at position 1. So we have a butane chain and it's an alcohol, so this would be butanol. So we're taking the ANE, we're removing the E from there and adding OL to get the alcohol. So we can also do another C4 chain. Where the OH group is now going to go at position 2. And so now we have to specify the location of that alcohol. So this is going to be 2-butanol. So I've underlined how we change the E to OL, and so that we're all on the same page here. This is the main functional group present in that parent, the OL, and the 2 is the position of that alcohol. So at this point we've exhausted all the possible constitutional isomers for the longest C4 chain. So let's go down to the C3 chain. So this is going to be a propane derivative. Let me just go ahead and number here. So we have to do two things. We have to add a methyl group and we have to add an alcohol. So in this case the methyl group has to go at C2, because if we add it to 1 or 3 we're getting back to the C4 chain. Now we need to add the alcohol. Let's just add it to position 1 to start off with. So instead of propane we have propanol, and we have a 2-methyl group. So we're going to say 2-methyl -1 propanol. So again, how does this work? The position 2 is telling you where this methyl group is bonded. The position 1 is then telling you where the hydroxyl group is bonded. And the propane is telling you it's the longest carbon chain. We can draw one more isomer of C3. So we have 1, 2, 3. This case we're going to put the OH group at position 2. And so now the name of this compound is going to be 2-methyl-2-propanol. So at that point, we've exhausted all the possible constitutional isomers for the alcohols. Let's move over to the ethers. So remember that the general formula for an ether is ROR prime. So you have an oxygen with 2 sigma bonds to carbons. So for the C4, so we're going to have a 4-carbon chain, and so we're going to put the oxygen in between sigma bonds at this point. So let's start off. We have a methyl group. Let's bond it to oxygen, and now we have 3 more carbons to account for. So at this point, the way we would name this is to look at the respective groups. So I'm going to use this red pen to sort of dissect. So there we have a methyl, and there we have a C3 chain, so propyl. So we would name this in alphabetical order: methyl, propyl, ether. We can do one more C4 derivative. So we've initially, in the first case, we had a 1-carbon unit. What if we do a 2-carbon unit? 2 carbons, then our oxygen, and then the remaining 2 carbons. So again, if we dissect, we have 2-carbon, 2-carbon. We would call this diethyl ether. So what we can do now is look at the constitutional isomers of the ethers. So I want to call this the C3. We sort of already did this for the C4 in the sense that we're going to take a methyl, bond it to oxygen, and in the initial one, methyl propyl ether, we had a straight chain. Instead of doing a straight chain, we're going to do a branching chain. So we need to account for an additional 2 carbons from that group. So if we do the same sort of analysis and dissect here, we have methyl, and dissect here, you can see it's at a branching point now. And so if we go ahead and number 1, 2, 3, that would be a 2-propyl. So we could call this, again, alphabetical methyl 2-propyl ether. So at this point, we've exhausted all the possible constitutional isomers for the ethers. But we can see in terms of a summary, given the molecular formula C4H10O, we can draw 4 possible alcohols, 3 possible ethers, for a total of 7 different constitutional isomers of either alcohols or ethers. Important to this is always determining the degrees of unsaturation first, because that's going to help you navigate towards which functional groups you can include or which ones you can definitely exclude.